The broadcast is now starting. All attendees are in listen-only mode.
Yeah, hi, this is Jim Palmeri. We'll be starting in about a minute. Just waiting for people to log in.
Hi, my name is Jim Palmeri. Welcome to the webinar on Cloud-Based Disaster Recovery as a Service. This event is sponsored by Agitare Technologies and DataGardens. This webinar is also being delivered as part of a local community group, Cloud Talk. Toddy Mladenoff and I are organizers of Cloud Talk, and Toddy is my business partner at Agitare Technologies. Cloud Talk is a community group of over 630 members that get together to discuss business, technology topics related to IT, DevOps, everything cloud. We do affiliate work with other community groups like Northwest Tech Alliance, run by Jason Aline. Welcome Cloud Talk, NWTA members, and other business associates and potential partners. We'll be covering two topics today. I'm the CEO of Agitare Technologies. We're a managed service provider, partner, and reseller of DataGardens Solutions. I'll be providing an overview of business continuity disaster recovery. Dr. Geoff Hayward, CEO of DataGardens, will be discussing cloud-based DR as a service, outlining DR architecture using the cloud, providing a demo of the DataGardens solution. We have time at the end of the presentation for questions and answers.
Quickly do a synopsis here. In terms of business continuity disaster recovery, it's the plans put in place so that business can function and continue during and after the disaster, and it's looking at people, processes, and resources. Make sure you've got an overarching plan. It's making sure you've got the appropriate decisions in place, and you know who the decision makers are. And for those that have gone through a simulation or real event, that's a big problem. Understanding mitigation of risks and setting the foundation for the DR strategy and plan. And then the disaster recovery is the process by which you come out of it, right? You're resuming business. You're going through a disruption event. You've got alternative processes in place to come out of it. You're provisioning resources. You're looking at your backup and replication of information. And you can think of it as an analogous to insurance policy, where you're looking at financial position of the company and protecting it, the reputation in the industry of your company, your competitive position where you have something that differentiates yourself from others, and then your customer and your employees, and it's protecting them. Causes of DR. So it's interesting. Quorum did a survey, and they said 95% of the causes are associated with hardware, human error, or software failure. And I don't know if you those remember the problem with Joyent, where they sent some commands out and shut down a whole bunch of servers. So when you look at 95%, there's about 5% that are environmental. So it's hurricanes, floods, earthquakes. People forget about DDoS and being hacked. And for the Cloud Talk members, back in April, we run on meetup.com, we host on meetup.com, and they had a DDoS attack, and nobody could log into the event. So we went through that. And then what I find most is there's business change, and that's what usually puts people in trouble, either business change or compliancy change. And what you've got are applications that maybe were classified as bronze. Now the business is gold. You know, there's a larger revenue stream coming in. The importance of the data is much higher, and people have out of compliance old run books. And when things go down, they don't properly represent the current state of the business. And this is the breakdown that Quorum found, that 55% were hardware failure, 22% were human error, 18% were software, and 5% were natural disaster. So some of the business impacts. So bottom line, if you don't have a DR plan, you're probably going to go out of business, or you're going to be out of business in a short period of time. This is some statistics from Cloud Tweaks that said 6% of the business goes out of business that without disaster recovery survive, and 43% never reopen, which I thought was some interesting facts. The impact of cost to the business. This is from Aberdeen Group. And it shows that the cost for downtime can reach into the hundreds of thousands for small to mid-sized business. If you remember, impact on human life when Frontier lost its cable and it took down some hospitals and pharmacies and people couldn't get service. And then in terms of reputation and regulations in the industry, Sony had some problems with their servers and they had a security data breach, and not only was it a reputation hit for their company, but they were fined. So those are things that you need to worry about and plan for. In terms of the cost of downtime, there's a variety of different attributes to look at. Two are recovery point objectives and recovery time objectives. It's how far back can you fail, and how much is 1 week's worth of data or 1 minute's worth of data, depending on your business model, and the recovery time objective, which is how long can you be without a system. And those are the considerations that as you start going through the business impact assessment and the business continuity process, you'll start looking at, by application and data, the types and impacts associated with labor, revenue, cost of data, the type of data, and the impact of an outage on your business and your customers. And it starts to become a balancing act now, where you're looking at cost and time, and you're starting to look at your replication strategies and your backup strategies, and do you have hot sites or cold sites? How much time does it take to move data back? How much time does it take to restore the systems? And that's where you start looking at other opportunities like disaster recovery using cloud-based solutions. So this is a good time for me to turn this over to Geoff, and Dr. Geoff Hayward from DataGardens, and he'll pick up the presentation on DR as a service.
Great. Well, thanks so much, Jim. Just want to check in. We were having some problems with audio earlier on. Can everyone hear me okay? Jim, can you hear me?
Yes, I can hear you.
Perfect. Well, yes, DataGardens sells a cloud-based disaster recovery software system, and we're very excited about the collaboration with Agitare, because Agitare can complement what we're doing by providing many of the higher-level services, business impact analysis, runbook automation, etc. There's a huge demand we're seeing right now for cloud-based disaster recovery. Gartner, for example, is predicting that by the end of this year, 30% of mid-sized companies will have moved to some form of cloud-based disaster recovery. And we're seeing two major reasons for this huge flux of customers into the cloud for disaster recovery. One is that conventional disaster recovery is very expensive. That dedicated recovery site, of course, all the physical and virtual costs associated with that, not to mention the WAN replication, the security, etc. But in addition to the cost, which is typically about 2.6 times that of your production data center, another major challenge with do-it-yourself disaster recovery is it turns out to be very difficult to spin up a replica of your data center in a remote site at a moment's notice. Just very challenging, requires expertise at so many different levels: storage, wide area network replication, security, virtualization, cloud, etc. So cloud-based disaster recovery is a solution to those two problems. This is the model that we see most often. Most of our customers deploy this type of use case. They keep their production systems in their private data centers, represented in this picture here by the green islands around the periphery. But they all win in multiple ways. They win because now they're able to amortize their capital and operating costs across a large subscriber base, so the costs go way, way down. They also win because they're able to leverage the expertise of companies like Agitare and the cloud provider to do all the heavy lifting when it comes to provisioning that or designing that DR architecture. And the third way they win is that these resources, these virtual machines in the cloud, are only going to get spun up if a disaster actually occurs. So under normal circumstances, you're just paying for off-site storage. And that's about comparable to what you're going to be paying for any cloud-based backup solution, and yet you're able to spin up an exact replica of your data center in the cloud in a few minutes. So it's a very attractive value proposition. The most common use case we see for the product is, as I mentioned, from a dedicated private data center to multi-tenant cloud. But the solution also supports private cloud deployments, the public cloud, of course, and hybrid cloud deployments. The product is called Safe Haven, And the Safe Haven cluster is dedicated to each end user, and a single Safe Haven cluster can protect up to 64 data centers, physical and virtual. So there's a lot of capability to grow. Of course, most customers are just protecting a single data center and a single virtual data center in the cloud. But there's a lot of capability to grow to many physical data centers and to load balance across multiple different clouds from different vendors if you should choose, and have different virtual data centers for different divisions of the company. Cloud-to-cloud disaster recovery is another major use case. These might be clouds provided by different vendors. For example, one might be vCloud Director and another might be a CenturyLink Cloud. And that solution, that sort of use case is also supported. Now, with that as a little bit of background on the business drivers, I'd like to move down to more of a technical level and explain a little bit about how this product works, and then would like to move into a live demonstration of a site-level failover. This slide here is going to build gradually and help us understand how Safe Haven works. As I mentioned, each end user is going to have what we call a Safe Haven cluster, which can include up to 64 data centers. In this case, I'm showing a simple Safe Haven cluster with just 2 data centers, a private data center belonging to the end user, and here's a cloud that might be from any one of a number of different cloud vendors. The first thing that we do to deploy Safe Haven is download a virtual appliance called a Safe Haven replication node. And this virtual appliance is very lightweight. It's 2 virtual CPU, 4 gigs of RAM, 15 gigs disk space. We then perform OS-level mirroring either through our agent or through third-party software RAID 1 to mirror all the writes from the primary data store onto, so they are presented also to the Safe Haven replication node, or SRN. The SRN then takes those changes and he can store local copies for rollback purposes. But his prime job is to buffer those changes and transmit them asynchronously into one or more clouds. There it saves the SRN in the cloud will save a persistent copy plus up to 2,048 checkpoints for rollback purposes. So there's continuous data protection. You can roll back to earlier points in time. Now, we present those those data images of the protected virtual and physical servers are presented as network drives to these proxy recovery servers or stubs that are registered in the cloud. Now, those are kept powered off under normal circumstances so that the costs of the solution really reduce essentially to that of storage in the cloud. But despite the fact that they're kept powered off, they're up to date on exact replicas in the production of what's in the production data center by virtue of the ongoing work of the Safe Haven replication node underneath the covers. Now, there's a couple more components. There's the Safe Haven console, which we'll see in a minute. It's responsible for, that's how the end user can administer this, the disaster recovery service. And all of those commands are sent to a central management server, or CMS, which is the clearinghouse for those commands. Then the CMS then fires them off to the appropriate SRNs and the appropriate sites and receives information back from those SRNs, conveys it back to the console. At a high level, that's the architecture and that's how the product works. I'm sure there might be some questions on that, and Jim, if you want to gather those questions and perhaps forward them to me at, as need be, eager to answer them as we go along. Jim, are there any questions at this stage that you'd like to forward?
You know, one thing, Geoff, can you talk a little bit about, you know, in terms of testing the system, you know, can you test a failover without affecting the production site?
Yeah, that's actually one of the core features of the product. We'll see that a little bit later, but one of the nice things about the product is that it can perform many disaster recovery tasks: failover, failback, migration, test failover, rollback, and it can do all of those at multiple levels, at the level of individual groups or entire data centers. So for example, here on this slide, I'm just going to show you a little bit about how the group structures work within Safe Haven. Each SRN can protect multiple what we call protection groups. These are groups of servers that are coupled in some way and all need to roll back to the same point in time. and they might have a particular recovery plan associated with them. You might need to bring up, say, the database server before the app server, before the web server. And if so, you can prescribe recovery plans for each of these protection groups. Now, these protection groups are shown schematically here as a green box. Notice that each active green box or protection group has a hidden replica on the other site. We're constantly replicating or synchronizing changes from the production instance to the hidden replica at all times, and saving checkpoints according to an automated schedule that the end user dictates on a group-by-group basis. Now, if we wanted to migrate this group, and I'm going to pick on group V3 here, from the source data center to the target data center, what we do is we perform a controlled shutdown according to the recovery plan in the source location, bring up, according to the recovery plan, the group in the target location, and reverse the orientation of updates, and then we're able to migrate back. And that is how you would normally handle, say, a power failure. If you're running on battery backup, you can evacuate all your servers into the cloud, experience no data loss whatsoever, and only a few minutes for application level recovery. If it is something worse than that, it's a catastrophic outage, you can't migrate because the systems are already dead, then you're going to fail over to the last checkpoint that we have in the cloud. Actually, you can fail over to any checkpoint in the cloud, but typically people pick the last one, and there will be a little bit of data loss. The minimum checkpointing interval is about 30 seconds, so there's not a lot of data loss even under these worst case scenarios. Now, that's really all I wanted to cover in the slide deck for now. Let me minimize that. Just check in with you again and see if there are any questions before we go further, Jim, and then I can go into the live demonstration.
Yeah, no, let's get right into the demonstration, Geoff, and then there are no questions right now.
Good stuff. Well, this here is the Safe Haven console. This is the console that is used for administration of disaster recovery services. And it looks a little bit similar to a vSphere client. A lot of people are familiar with that sort of a layout. Over here on the left is a navigation tree. And at the root of the tree is the cluster. Again, there's a dedicated cluster for each customer. The end user, that customer is the only person who has any of the replication traffic. All of this lives entirely within his administrative control, and no other customer is able to share in that cluster whatsoever. This particular cluster has got 3 data centers in it. A private data center, which is actually our data center where I'm calling from. We're located in Western Canada. This is a CenturyLink cloud in Sterling, Virginia. And this is a cloud from another cloud provider that's vCloud Director based, which is actually in Washington, D.C. So if I go back to my navigation tree and expand down, we get to the site level or the data center level, and we expand down one level further, and we can see that we have one of those Safe Haven replication nodes, or SRNs, in each of the data centers. Now, if I expand one level further, I get to the level of those protection groups, and we have 5 of the protection groups that are all active in our private data center. Now, over here in the data panel to the right, you can see a lot of information about each protection group. I'll just adjust it a bit so that we can see a little bit better. Here we can see information about the size of the protection group, how much data remains to sync across the network. You can rate limit the amount of bandwidth, the wide area network bandwidth that's allowed for wide area network replication. And here's checkpointing interval. This one's got a checkpointing interval of 1 hour, as it turns out. You can set that to from 60 minutes down to, say, 30 seconds if you want, or 4 hours, whatever you want. It's very straightforward to make that change, and I'll make it now. So you can see when I edit the checkpointing period, a new job opens down here in the progress panel at the bottom, and we've just changed the checkpointing interval from 1 hour to 10 minutes. Now, if I want to look at the history of all checkpoints, I can see that we have a scrolling log of those. And the number that are actually retained in the cloud is determined by how much storage we provision for those checkpoints. Now, in this case, we've only provisioned enough storage for 1,150 checkpoints. But it's really limited. The number we retain is limited by the amount of storage that you have for the checkpoints in the cloud with a maximum of 2,048. Okay, well with that background, let me show you a little bit more about here. There are 2 VMs within this group. Within this group here, we have 3 VMs, each with 2 hard drives. And information about the recovery plans is all here in the, you can see you can change the recovery plans both in the production data center and in the cloud. We've set a very simple recovery plan with no delays and no special actions just because we're doing a demo here today and we want to keep it quick. Okay, with that background, let me go into my private data center, and we can see that this is a vSphere client. Most of the end users today are using VMware. We're not limited to working with VMware, but most people are familiar with this VMware vSphere client. And you can see that the 5 protection groups that are active in our private data center correspond to these 5 vApps and a total of 11 virtual machines, all powered on. Let me open up a console to one of them. And this one, I think, is a Windows 2003 box. And we're just going to log in and write some data there. Whoops, mistyped the password. Good. Now the replication is LUN-level replication, and it's application agnostic, but what I thought I'd do is just write something here in a Paint application. Hi. And we're going, this particular protection group, I believe, will end up going to, finance is going to go to Washington, D.C. One of the interesting things about this product is that different protection groups can be replicated in different clouds from different vendors and different platforms, different hypervisors. So this one is going to, this is going to be cloud. Let me save that. And let me open up another console for something that is going to go to the CenturyLink cloud. And we'll do something similar there. Good. And okay, so we're on our way to the CenturyLink cloud in that case. We're going to save that. Let's go back to our Safe Haven console, and we've just made changes to those protection groups. And so that we don't have to wait for the next automatic checkpoint, let me take a manual one right now. I just right-click on the protection group and select Create Checkpoint from the drop-down menu. And you notice another job starts up down here in the Progress panel. Similarly, let me go to this one, which is the one we changed and it's on its way to CenturyLink Cloud. I'll create a checkpoint there. And those jobs finish up very quickly. So now we've made some changes. Now what I'd like to do is emulate a catastrophic outage of our production data center. And so we're going to fail over to the last checkpoint that we have in the cloud. And let me, in order to show that we will actually lose some data when we have that sort of a situation, let me write a little bit more data here. In each case, I'll save it locally, but I won't wait for the next automatic checkpoint, and I won't take a manual one. So we expect to lose this word lost in both cases as we fail over to the different clouds. One of the things that's so exciting about this product, okay, sorry, let me just initiate the failover. You just click on the site, select failover from the drop-down menu, and we confirm that we do indeed want to failover. And it's going to select all of the checkpoints. Now, before I fail over, I should actually show you the clouds that we're failing over into. Great. So here's the finance group, the finance group and IT branch are in the cloud in Washington, D.C. This is the vCloud Director one. Here is the one for CenturyLink, and you see that the 3 groups that have their replicas here are all powered off. You can see that they're all powered off in the CenturyLink cloud. So there's 2 different clouds, and you can see that all of the VMs in the remote clouds are stopped. This one here is the Safe Haven replication node, and that's actually running, of course. Okay, so let's go back. We're initiating the failover. A bunch of new jobs start up. They'll finish very quickly here, next 30 seconds or so. And once those finish, we'll then issue commands to the different clouds to automatically power on all of them. We're issuing those now, so I better get over here and refresh quickly, because this is probably already, yes, you can see they're already starting up. And they're going to start up according to the recovery plans that we set through our console. So if there's any dependencies, we'll make sure that the first guys get up before. Okay, so we're already powered on. I think it was this server here that I made the changes to. And that's going to power on in just a second, or boot up in just a second. Let me go over the CenturyLink cloud and just check their command queue. I imagine all of the commands to power on have already completed by now, and indeed they have. So let me just go back, and we should see all of these groups are now, as soon as this refreshes, you can see that they're all powered on now. So the time to power on those VMs was less than a minute. For 2 different clouds, very different, they can be anywhere in the world. We're already booted up over here on this guy. So this is all, you can see the failover times are indeed very, very fast. So I'm just issuing Control-Alt-Delete. We're going to boot in, or sorry, we're going to log in. And that's the shutdown event tracker. Windows just telling me, hey, I lost power. That's okay. We expect that. And there's our console. And now this one here is in Washington, D.C. on vCloud Director. Now we can see that the data that we wrote back in our original production data center. Let's go over to the CenturyLink cloud and notice that here we updated a Windows 2003 box. If I just check in on what its IP address is, there it is. I'm going to RDP into that. And yes, we're booted up there too. And we'll just log in. And we should see all the changes we wrote back in the original production data center. Shutdown event tracker again. And there's the data that we wrote back in the original production data center. So that's giving you a sense of how quickly you can fail over an entire data center. In this case, it was only 11 VMs, but we have several customers up in the hundreds of VMs. The failover times are about a minute or so, a little bit less than a minute, to power on the VMs. Additional time, of course, to boot up the VMs. And now we can work in the cloud, and I'll do that. And just check in with you, Jim, to see if there are any questions that have come up as I've been talking here. I'm just, I'll do some more work in the cloud. And if we have enough time.
Any questions? If you have questions, feel free to submit them. Go ahead, Jeff.
Okay, so we can just do some work here in the cloud. And
the one thing, Jeff, we got one here. In terms of handling IP addresses, can you talk a little bit about that when you're
yeah, that's a great question. That's a great question. The solution enables you to keep either the original IP addresses that you have for the production systems in the cloud, and so your recovery systems will come up with the same IP addresses as they have in your production data center. That's one option. But that's not supported by all clouds. Some clouds require you to take an IP address range that they provide. If so, we automatically change the IP address so that upon recovery, it's going to come up with the correct IP address. But the good news is that IP address is known at the time of onboarding so that you can test your DNS to make sure that the VMs are recovering and the applications are working according to your expectations when they fail over into the cloud. And so yes, that can all be tested through the test failover feature long before any disaster occurs. So I've been working here, done a little bit of work on the cloud, and notice that all of the VMs are in failover state in the different clouds. They've gone, 3 of the groups have gone one way, and 2 of the groups have gone to another cloud on a different cloud platform. To fail back, the first thing I do is I just go to the site and I select fail back. It gives me some warnings. And clicking forward, the first stage of failback is to first do some health checks, make sure that we can see the data center. Remember, we've had a disaster here, and there could be we could be unable to see certain systems. We then do something called split brain resolution. If there are some rogue servers that are surviving that would cause conflicts, we deal with those. And then we reestablish synchronization. So now the synchronization is from the cloud back to the original production data center. But throughout this time that I've initiated the first phase of failback, I can keep on working in the cloud, and all these changes are going to make their way back to the original production data center. And similarly, we could do some more changes over here, and all of those changes will make their way back to the original production data center. So we're going back to the console. We have finished the first phase of failback, and now we're on the second phase. Now this is the phase where we're actually going to migrate the VMs back from the cloud to the original production data center. This is a lossless operation, so there will be no data lost whatsoever as we migrate back from the cloud. What we do is we issue those shutdown plans that you saw in the recovery planning tab. So bring down the servers in the cloud according to the sequence. We then transfer any residual changes into the original production data center. You can see there is some data that's been written in the cloud. That's to be expected. That's data that gets written on boot up every time a server boots up. So there is a little bit of writes there. We're going to transmit those residual changes and then migrate the VMs back. Now, we can see these VMs have already been powered off in the cloud. And so if we go back here and go to refresh our vCloud director in, whoops, let me just adjust that. And we refresh, we'll see that these guys have already stopped. And similarly, we'll go up to the command queue here for the CenturyLink cloud. And if we just, yes, everything's already finished. Everything should be powered off in the CenturyLink cloud as well. Oh, I have to go back a bit here. And you can see that everything is already powered off. So you're only paying for those memory and CPU resources in the cloud if a disaster you're actually running in the cloud. We've already, on failback, already powered off. Let me go back to the vSphere client. And as we watch, we'll see all of those VMs powering back on according to the recovery plans. And they're starting to do so right now. You can see the IT branch is now coming back. Finance branch is coming back right now. And once they power on and boot up, we'll have all of the changes that we wrote in the cloud. Now, this is a good time for another pause here to answer questions, Jim, if there are any, because unlike a cloud provider, we have just some low-end equipment here, and there's going to be a little bit of a boot storm as all those guys power on. So we're going to have a few minutes to wait before the boot ups will complete. If there are any good questions right now, we could deal with them.
Yeah, Geoff, can you talk a little bit about reporting features in the product? Specifically, can you talk a little bit about alerts, and if alerts and failures are detected, how does the product handle it?
Sure. Sure. As you can see, we're all powered on in our original production data center. As I mentioned, it'll take a little bit longer to boot those guys up. So let me just deal with that reporting question. You can configure failure notification right here. So for this particular safe haven cluster, this is my email address. I get notifications if anything happened here. But you can just update this with your Gmail account, and whoever is listed here is going to get notifications when we detect power outages, failures of any kind. They will report them here. Another way in which we report problems is through a weekly report, and it provides information about what the RPO and RTO that you would achieve if you had a disaster right at the time of the report. And if we're falling behind because there's not enough bandwidth that's been allocated to handle all of the changes, and it's not meeting your RPO objectives, you'll see that flagged in your weekly report, and that gives you plenty of time to do failover tests and to ensure that your system is running the way you expect it to be. So let me go back now, and actually, I still left these guys open. So now they, let me just show Control-Alt-Delete here. Shut down Event Tracker. So there's the data that we wrote in the cloud in one case. And go over to this one. And this one, I think, was the one that went over to CenturyLink. And there's all the data that we wrote in that cloud. So the high-level summary, we can do a site-level failover in about a minute or so to different clouds. We support CenturyLink, vCloud Director, of course, OpenStack, different cloud platforms. And do full runbook automation, group consistency, failover, failback, migrate, test failover, rollback, all supported within the product along with failure notification and automated reporting. And that's a high level of how the product works. I want to pass it back maybe to you, Jim, to talk a little bit about, we provide the infrastructure level services. But for many customers, what's more important or equally important is that touch, making sure that the runbook automation is designed correctly, the business impact analysis has been done, and the higher level services that go right back to make sure you're covered in the case of a disaster. That's more provided by Agitare than by DataGardens. So Jim, maybe I could pass that back to you and you could tell us, take us forward from here, pretty much at the end of what I intended to show, and we could also answer questions if there are any.
Great, thank you, Geoff. And if you have questions for Geoff, type them in. It was very good, thank you. I do have one. Can you explain what happens to the word lost in the failback?
Oh, yes. So in the event that you've got power failure, you still have battery backup, the servers are still up in the production site. There's something for us to deal with. You're not going to lose any data. But what if they're already dead? What if you've got a smoking crater where your data center used to be? In that situation, we're going to fail over to the last checkpoint that we have in the cloud. And in the case that I demonstrated today, that last checkpoint was taken before I wrote the word lost. So we do lose that word. And that's an important thing to realize, that disaster recovery systems are designed intentionally to have asynchronous replication so it doesn't impact your local performance when we replicate things to the cloud. A negative consequence of not impacting your local performance is that we are a little bit behind. And in this case, the amount that you're behind can be as little as 30 seconds, but you will lose some data if you have a catastrophic outage in the production site. Now, on the way back, as you can see, we lose no data at all, and that's because it's a controlled shutdown. In terms of what happens to the word lost, any surviving systems in the production center that did have that saved will now, you have a choice whether to retain those, if they were in fact the versions that you wanted. But typically when you've been working in the cloud for a while, you want to retain the versions in the cloud, in which case we just discard the original versions in the production data center.
Great, thank you. Any other questions? Any support for Linux, Unix, mainframe systems?
We do support pretty much all flavors of Linux that you can think of. There's a lot of them. We have a specific support matrix, which we can share to any interested customers, but pretty much most flavors of Linux that you can think of are supported. As for mainframes, no, this is primarily an x86 architecture. It does support physical and virtual, but typically for x86 platform, not for mainframe.
Excellent. Any other questions? Great. Well, Geoff, thank you very much. And if you put the last slide up.
Oh, sure. Yeah.
So as Geoff was mentioning, the working relationship between Agitare Technology and DataGardens is very strong. We're both providing reselling for DataGardens, and we do business continuity disaster recovery, BIA assessment. We can help you understand how to map your processes into the solution. We can work with you to come up with the BC side of the house or implementing the DR side of the house, and we'd be happy to do quotes for anyone. And we have our contact information on this last slide. What we'll be doing is we'll send out we'll edit this a little bit, maybe to clean it up at the beginning, but we'll send out a link to the edited recorded session. And if you are interested in talking further about the DataGardens solution or managed services that we could provide you, please contact myself or Tati Mladenoff at the information above. And also check out the resource site on our Agitare site. Tati's been writing some really great articles on cloud-based DR, determining cost of downtime, some really good solution papers out there. So I'd like to thank everybody for attending. It says, how long have you all been partners? We're actually, we're going on about a month and a half. We just became a partner of DataGardens a while ago. Any other questions? Excellent. Well, thank you very much for attending. Thanks, Geoff.
Thanks so much, everyone.
Okay, bye-bye.